In this video, we want to learn how we can factor expressions with fractional coefficients. Our first example is 1/2 x to the 2 plus 2x plus 3 over 2. As you can see, we have two fractions here, 1 over 2 and 3 over 2. And if we want to factor this expression in this form, it's a little difficult. So, it's better idea to first get rid of these fractions here. We try to get rid of 1/2 and 3 over 2 first. Then, we factor the expression without fractions. But how we can get rid of 1/2 and 3 over 2? One idea that you can find in many textbooks and videos is to factor 1/2. But factoring 1/2 is a little hard, and it makes solving the question a little challenging. The easier method is, instead of factoring 1/2, is to get rid of fractions. How? Simply multiply this expression, multiply all of this expression by 2. If we multiply all of this expression by 2, what happens? 2 times 1/2 x2 is x to the 2. 2 times 2x is 4x. 2 times 3 over 2, 2 with 2 cancels, and we have only 3. But we know that if we multiply an expression by something, by a number, we have to multiply it by its reciprocal. So basically, because if we multiply this expression by 2, we have to do the opposite to cancel the effect of multiplying by 2. What is the opposite of this operation? Multiply by 1/2. If you multiply an expression by 2 and then multiply it by 1/2, because these two cancel each other, so you didn't change the value of the expression. So for that reason, now simply we put a bracket for this expression and we put 1/2 outside. So the process is very simple. To get rid of fractions, simply multiply by a number to get rid of these denominators. Then reciprocal of that number you can put outside as a coefficient for all of the expression. For example, suppose you have something like 2 over 3x to the 2 plus 5 over 6x plus 7, something like this. Here, to get rid of these denominators, what you have to do? Simply you multiply all of this expression by 6. Then, after you multiply 6 in every term and you get rid of the denominators, you put a bracket around that for that, and then 1 over 6 outside. This is the method that you can apply for every question. Now focus on the inside of this bracket. We have x to the 2 plus 4x plus 3. As you can see here, this is a simple trinomial, and we know how to factor trinomials. We put 1/2 outside. Then for factoring this trinomial, we put x in each bracket, and then we look for two numbers that their product is 3 and their sum is 4. What are two numbers that their product is 3, their sum is 4? Those numbers are 1 and 3. 1 times 3 is 3, 1 plus 3 is 4. And this is the factored form of this expression. Let me show you another example. 1/3 x to the 2 plus 1/3 x minus 4. Here, immediately we notice that if we multiply this expression by 3, we can get rid of these denominators. So we multiply all of this expression by 3. If we multiply this term by 3, then we have x to the 2. If we multiply this term by 3, then we have only x. And if we multiply this term by 3, then we have minus 12. But because we multiplied this expression by 3, we have to put a 1/3 outside, the reciprocal of the number that we multiplied. Now we can factor this trinomial in the bracket, x in each bracket. We look for two numbers that their product is negative 12 and their sum is 1. Attention, coefficient of x here is 1. So we want two numbers that their product is negative 12 and their sum is 1. What are those numbers? 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. And this is the factored form of this expression. So the technique is this. Always multiply the expression by a number to get rid of all denominators, then reciprocal of that number outside of the bracket, because we don't want to change the expression, but we want to convert the expression from this ugly form to this form without fraction. And still we have fraction, but it is outside, so we are not worried for that. The inside is the thing that we want to factor. Look at the next example. 1/5 x to the 2 plus 1 over 2x plus 1/5 again. Here we have 5 and 2 in the denominator. What is the number that if we multiply all of this expression by that number, 5 and 2 cancels? 10. So we multiply all of this expression, every single term in this expression, by 10. Then we have, what is this term if we multiply it by 10? 10 with 5 cancels, a 2 remains, so we have 2x to the 2. 10 times 1 over 2x, 10 divided by 2 is 5, so we have 5x. And finally 10 times 1/5 is 10 over 5 or 2. But don't forget, you have to put a 1 over 10 outside. And please, attention, if you multiply 1 over 10 in every single term, then you have the original expression. By this technique, we move the fraction to the outside of the bracket. And now we focus in the factoring of this trinomial in the bracket. For factoring this trinomial, because the leading coefficient is not 1, this coefficient is not 1. So the technique is this. We multiply this leading coefficient by the constant. 2 times 2 is 4. Then we look for two numbers that their product is 4 and their sum is this 5. So we look for two numbers that their sum is 5 and their product is 4. Two numbers that their product is 4, their sum is 5, those numbers are 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. So now we use this technique. 2x to the 2. We split this middle term to two terms. What was the numbers that we find from the product 4? The sum is 5. 1 and 4. So we split 5x and we write this term in the form of 1x plus 4x plus 2. We write this middle term in the form of x plus 4x. Now, if you pay attention, if we consider these two terms as a group and these two terms as a group, we can factor something from each group. From the first two terms, we can factor x. Then we have 2x plus 1. From the next two terms, we can factor a 2, and then we have 2x plus 1 again. And finally, we have 1 over 10. This part is common between these two. So we have 2x plus 1. We factor that common term, and then from here we have x. From the next term, we have plus 2. And this is the factored form of this expression here. If you want to learn more about this technique that I used here for factoring this trinomial, you can watch my video about factoring trinomials. But if you already know how to factor the trinomials, any method that you can get this answer is fine. You don't need to use any special method. As long as you can factor this trinomial, you should be okay. And now look at this example. 1/2 x to the 2 minus 1/3 x minus 5 over 6. By looking at the denominators, we can see that we have 2, 3, 6. How we can get rid of these numbers? By multiplying this expression by 6. So we multiply all of this by 6. And of course, because we want to multiply all of the expression by 6, we have to put a 1 over 6 outside of the bracket. 6 times 1 half x2, 6 times 1 half x2, 6 with 2 cancels, we have 3x2. So 3x2. 6 times negative 1/3 x is negative 2x, because 3 with 6 cancels, we have a 2. 2 times negative x is negative 2x. And finally 6 times negative 5/6 is negative 5. So we have a negative 5 here. Now we have a simple trinomial in the bracket. We use the method we used in the previous question for factoring this trinomial. 3x to the 2 minus 2x minus 5. 3 times negative 5 is negative 15. Now we look for two numbers that the product is negative 15, their sum is negative 2. What are those numbers? Those numbers are negative 5 and 3. So we write 1/6 times, we split this middle term and we write it as negative 5x plus 3x minus 5. Negative 5x plus 3x is exactly negative 2x. Negative 5 plus 3 is negative 2. Negative 5 times 3 is negative 15. It should be this number. Now, similar to the previous question, we factor common term from these two first term, which it is x, and then we have this. And we don't have anything to factor from these two, so we leave it as 3x minus 5. Now, as you can see, 3x minus 5, between these two, between this term and this term, it is common. So we factor 3x minus 5, 1/6 times 3x minus 5, and then from here we have x, and from here we have 1. This is the factored form of this expression given here. 0.1 x to the 2 plus 0.5 x minus 0.6. Attention, 0.1 is 1/10, 0.5 is 5/10, 0.6 is 6/10. So basically we want to get rid of these decimal numbers, we want to get rid of these fractions. How we can get rid of 0.1, 0.5, 0.6? By multiplying everything by 10. So if we multiply all of these terms by 10, then we have, of course we have to put the 1/10 outside, then we multiply every single term by 10. 10 times 0.1 is 1, so just we have x to the 2. Then 10 times 0.5x is 5x. 10 times negative 0.6 is negative 6. Now here we want to factor the expression in the bracket, which is very simple, trinomial. Two numbers that their product is negative 6, their sum is 5. Those numbers are 6 and negative 1. 6 times negative 1 is negative 6. 6 plus negative 1 is 5. So this is the factored form for this given expression here. As you can see, this method is much easier than factoring 0.1 or something like that. The method that we use in this video is that we multiply the expression by a number, and then reciprocal of that number which we multiply the expression by, we put in the outside of the bracket. Look at this example, 1/2 x to the 2 minus 8. We have a coefficient, a simple coefficient 1/2, but we don't like 1/2. So how we can get it of 1/2? Multiply everything by 2. If we multiply this expression by 2, then we have, if we multiply this term by 2, it would be x to the 2. Negative 8 times 2, negative 16. But because we multiplied by 2, we have to put 1/2 outside. Now look at the bracket. It would be 1/2 times x minus 4 times x plus 4. From here to here, we used the difference of a squares identity. If you remember this identity, this famous identity, very, very important identity for factoring expressions, we use this identity for factoring x to the 2 minus 16. 16 is 4 to the 2. X to the 2 is a to the 2. We can factor it as a minus b, x minus 4 times x plus 4. And this is the factored form of this expression. (1/8 x to the 2 minus 1/18). y to the 2. We have 8 in the denominator and 18. What is the number that if we multiply it, we can get rid of 1 over 8 and 1 over 18. Basically, we can get rid of these denominators. We have to find the least common multiple of 8 and 18. Attention, 8 is 2 to the 3 and 18 is 2 times 3 to the 2. The least common multiple of 2 to the 3 and 2 times 3 to the 2 is 2 to the 3 times by 3 to the 2, which is 72. So we multiply this expression by 72, because when we multiply by 72 we can get rid of 8 and 18, and of course we have to put 1 over 72 outside. So we have 1 over 72. Then if we multiply this number 1 over 8 by 72, 72 times 1 over 8 is 72 over 8, which is 9. So 9x to the 2 minus 72 divided by 18 is 4, minus 4y to the 2. Now look at the inside of the bracket. Again, we can use this identity. A to the 2 minus b to the 2 is a minus b times a plus b, the difference of a square's identity. Based on this identity, we can factor this as 1 over 72 times by 3x minus y, 3x plus y. Before I show you the next example, let me show you another method. Not another method, but a little different method for solving this question. 1 over 8 x to the 2 minus 1 over 18 y to the 2. Here we multiply everything by 72, and because of that we put 1 over 72 outside. But you can multiply this expression by a smaller number, and then you can factor this expression. But if you ask me, I prefer this method compared to this method, which I will show you in a moment. But again, it's not bad to see this method as well. Here I want to multiply this term, this expression here, by 2, only 2. And because I want to multiply by 2, I have to put a 1/2 outside. If we multiply this term by 2, 2 times 1 over 8 would be 1 over 4. x2 minus, if you multiply 2 by this, 2 over 18 is 1 over 9. The reason that here we can do this is that by doing this here and in this term, we have complete squares, if you pay attention. And again, with the aim of difference of a squares identity, with the aim of this identity, we can factor the bracket. So we can factor this in the form of 1/2, then 1/2 x minus 1/3 y times 1/2 x plus 1/3 y. This is another form of factoring this expression. But again, between these two methods, I prefer this first method compared to this one, because here in the factored expressions we don't have any fraction anymore, but still here we have fractions. But this is another method. It's up to you which method do you like to use for solving and factoring this expression. Now look at this example. 0.25 x to the 2 minus 9y to the 2. Let me remind you, 0.5 is 1/2. 0.25 is 1/4. Because basically this is 25 over 100, which if you simplify it is 1/4. 0.125 is 1 over 8. It's not bad to keep these in your head. Now here we have 0.25. First, I write this in the form of 1/4 x2 minus 9y2. Without multiplying this expression by anything, you can factor this right away in the form of 1/2 x minus 3y, 1/2 x plus 3y. And this answer is completely fine. And again, attention, here we use again this identity. A2 minus B2 is A minus B times a plus b. From a to, how we get a? By taking a square root of a to the 2, we have a. So here in this question, if we take a square root of 1/4 of x to the 2, a square root of 1/4 is 1/2, a square root of x to the 2 is x. And a square root of 9y to the 2 is 3y. But if you want to follow the method that we used in the previous questions, and you don't like to have fraction in your brackets, another way for factoring this expression is, so we have this expression. If we want to follow the methods that we used in the previous questions, first we multiply all of these expressions by 4 to get rid of fractions. If we multiply everything by 4, then we have x to the 2 minus 36y to the 2. But because we multiplied this by 4, we multiply this term by 4, and we multiply this term by 4, we have to put a 1/4 outside. Then we leave this 1/4 outside, and we can factor this as x minus 6y, x plus 6y. This is another form of the factored form of this expression. This is the answer. This is also the answer. Maybe you ask yourself why the answers are different. No, the answers are not different. They look different. It is like saying these two are different. Are these two really different? No. This is 6. This is also 6. But they look different. And here, if you pay attention, please let me describe this. What is 1/4? 1/4 is 1/2 times 1/2. If you multiply this 1/2 in this bracket, then you would get this expression. And if you multiply this 1/2 in the second bracket, you would get this bracket. So, as you can see, the answers are exactly the same, but they look a little different. I prefer this answer compared to this answer. But it's up to you which method do you like to use to factor this expression. I hope by watching this video now you have learned how we can factor expressions with fractional coefficients. If you like this video, please subscribe in my channel and see you in the next videos.